digital transformation, especially the adoption of IR 4.0 technologies such as IoT and many more. So hopefully that, by the end of this year, let's end the year with a big bang. Since this is the 12th installment, December 2021, we hope that, it's to be better and more prosperous to all of you. So today we have a very, very great lineup of industry speakers, very interesting topics on a lot of application, case studies, and maybe their experiences in areas such as smart cities development, digital transformation, smart building, and also industrial IoT. So we have a lineup about 4 topics here, and maybe for a start, I would like to quickly introduce to you for the first speaker so that we can go straight to the point. But if you have any questions, you just either raise your hands or you can also put into your chat box, and the admin, if you still want to pick, the admin will unmute you and you can talk directly. So the questions can come from the Zoom link that we have here, the chat, or also through our Facebook Live. So welcome again. So let's go for the first speaker. The first speaker is, before that, I just forgot to introduce myself. I'm Mazlan Abbas. I'm from Favoriot. It's also an IoT company. And our next speaker is also my colleague from Favoriot. He is Dr. Gopinath. He's the CTO and also the co-founder of the company. Just a little bit background about Dr. Gopinath. He's actually focusing on areas like IoT platform and solution. He has a doctorate, master's, and bachelor's from USM in computer science. He also has architected many IoT solutions and in the current and also previous organizations. So he has many years of experience in various of these IT industries, and his focus now is mainly in R&D. He's the expert in IPv6 and also IoT, and he has been leading this IT standardization body. He's the chairman of the IoT and Sustainable City of Working Group under MTSFB. So his role is actually to promote IoT and also create the IoT standards, especially in Malaysia. So without further ado, I'd like to get Dr. Gopi on stage or on the screen, okay, to talk about his topic. Thank you, Dr. Gopi, please.
Thank you, Dr. Mazlan, for your kind words. And first of all, I'd like to thank my IOTA for giving me the opportunity to share some information about the topic that I've chose today. So about 15-20 minutes. So let's see what I can actually share that could benefit the community here. Now, the topic that I'm going to share is an interoperable smart city IoT platform. So let me just share my screen first. Now, if you talk about, my IoT is specifically on Internet of Things, and Internet of Things cuts across various sectors, and smart city is just one of it. And within the smart city, there are many issues that need to be resolved first so that you can actually implement wide-scale implementation of any use cases within smart city. But first of all, let us see what is actually the goal of smart sustainable cities so that we understand the need and how we can actually position ourselves or direct our use cases for the specific purpose. But if you look at the goals of smart sustainable cities, it's actually to provide better living, create more opportunities, support stronger and more cohesive communities, improve quality of life. Now, what it says is that when we build a city, it is not only for the benefits of showing off or so on. It's actually for the purpose of the community or the citizens who's going to say they're going to benefit it. If that doesn't serve the purpose, and I think it doesn't make any good of having a smart sustainable city. And of course, having a lot of resources, public resources that we have, such as the water, electricity, and so on, it is also imperative that to make better use of the public resources, how the smart city can be better use. And of course, the last part, the third goal is set to reduce the operational cost of public administration. Now, smart city doesn't come, on its own. It must be from somewhere. So I see it as a convergence of various technology. As we can see, of course, we have other technologies. We have 5G, we have artificial intelligence, and so on. But what makes a city a smart city is basically a data that is collected from various sources. One of the main components is IoT. And when you talk about IoT, it's the sensors that is being deployed, the data from various other sources as well. And the data that is generated is actually creates a big volume of data, which would be useful for a very specific purpose within smart city. It could be monitoring the environment, monitoring the drainage system, or the entire ecosystem for smart city for better livability. Right, so a convergence is very much important and it's required. Having said that, if you talk about big data, of course, you also have data analytics behind it for very specific cases, right? So not all big data model or big data framework could fit into all the use cases. It must be very domain specific for that matter. And if you look into the architectural principle of smart city, there are a few. This is a good design approach for smart city. One is that layered structure so that you can fit in or adopt any new technologies that you want to deploy. Flexible enough so that any solution that to be deployed could be easily integrated without much hassle. Standard base, I will come to this later, why standard base is important aspect when building a smart city. Technology and vendor independence, this is important so that we don't have any lock-in issues of any solutions. Fault tolerance, availability, scalability, and interoperability. Now, one of the main important or main issue when we want to deploy a smart city is the interoperability part of it. Right? So what is the main challenge that we have? So when you talk or when you see the interoperability, so you must understand that, even for IoT solution, for smart city use cases, it is not that one single technology in the market that can deliver a complete end-to-end solution. Everyone will need to play a role, a device manufacturer, a solution, a connectivity provider, a platform provider, an application builder, and so on, right? Then only we can say that, we could have a complete solution and it's easier to integrate that way. Now, one of the interoperability challenges that you can see is that first is that if we do not have interoperability, it actually hampered the scalability of it. Meaning to say if you have, a specific vendor or solution from an organization A, which is deploying in a vertical based solution. And then we have another solution, solution B, which have another vertical solution, end-to-end solution. Now, if we keep on adding this solution to a same smart city, what would happen is that it would only increases the cost in the long run. Why I say so is because you need to have an independent, a separate end-to-end solution for it. The other issues that we can see is actually on the technology stability and loss of authority. Why I say loss of authority is because if, say, for example, vendor lock in as an issue, right? So how do you access the data that has been, specific need for specific time? How do you integrate the data from a specific vendor to another set of data? So you don't have that authority if we, if we actually get the vendors, very specific vendor to build. And having said that, it is important, right, for us to have a common framework, a common smart city platform for its purpose. And for that, I think smart city architecture for interoperability, there are three main areas. The first, it should be open. It should be follow the industry standard. So that, industry standard, there are so many industry standards for smart cities specifically, from ISO, from ITUT, and also, of course, various standardization body. Now we just need to focus on one area so that all the solutions that need to be integrated into the smart city solution could be easily, merged. No, you see, one thing people would always think is that, if you make it open, it would not be good for some vendors. It's not so, right? So, for software-driven technology. So the focus of hardware is only on, creating a better hardware. Now, if you have a common software-driven technology, specifically on the communication protocol, right, which is globally acceptable, and you don't put your own proprietary protocol, which hinders the interoperability for it, then it's good for both the end solution, the end provider, as well as those who are manufacturer of these devices and so on. The third is that the open interface, right? So there are many open interfaces. In fact, most of the solution, end-to-end solutions are using the open spaces. Gone are the days, specifically, Zigbee proprietary protocol or other proprietary protocol. People are moving away from that direction, right? So they want to ensure that, their solution, their devices, right, can use these open interfaces. Open interfaces could be, simple as, MQTT, CoAP, and so on and so forth. Now, one of the approach that we have been looking into is this, which is adopted from Inter-IoT project from Europe. So this is a end-to-end interoperable framework, which is adapted and currently being applied in our company, which is Favoriot. So we have different levels of different layers of interoperability. It could be device-to-device communication, which is hard to do. I know it's not easy to do a device-to-device interoperability. We have a networking interoperability. It could be, say, for example, multi-hopping. It could be mobility purposes and so on. Then we have M2M. M2M is not machine-to-machine. In this aspect, it is actually middleware to middleware. And then we have at the application layer interoperability. Then we also have the data or semantic layer interoperability. So like that, there are various stages of interoperability. And one platform can also be interoperable with the another platform. That is another aspect as well. And it's not easy to build of this interoperability at different layer. Now for that, what we have, actually we are focusing is a look into the benefit of it and then focus on a specific area. Say, for example, device level interoperability. The purpose is that to have as many devices to be fit easily into the platform, right? And it actually accelerates the growth of the smart objects. Then we have middle level, right? Middleware interoperability, then application and data semantic. Favoriot focuses on of course, our final goal is to have everything if possible, but as a start, we focus on the middleware interoperability, which supports independently of any hardware, any communication protocol that is out there. And slowly we add on all the various layers of interoperability in the coming. So how do we do that, right? So if you look into this, there are various solutions that uses various smart sensors. Could be mobility, people from using smartphones and so on, smart environment and so on. What is required is that using the specific communication messages and then specific documentation that has been built. So we give that to all the developer, all the device manufacturer. And of course, this is an open kind of documentation, open standard, is not a proprietary, so that they can use it to integrate to the platform. And the purpose here is that to aggregate all the data in one place so that you can cross-reference, cross-use it for data analytics and so forth. So this is just how we do it. We started off with the Favoriot platform for IoT specifically, which extended to smart city solutions. Could be any data sources using any communication protocols, Could be, a development kit. It could be off-the-shelf devices. The source of data could also be smartphones, for example, right? Where people tweet, people, share information, or it could be from external data sources. So all this information from various ways of communicating merges into a platform, and we have various components within the platform that caters specifically for that, any use cases that are going to be built on top of it. Using all the, specific, platform that we have built, it can be easily integrated with any purpose, for any purposes. Say, for example, you want to use the same platform for building a smart street light, or, for example, for an environmental monitoring. So you can use the same thing to do that, right? And also, of course, in some cases, it could be a custom-based analytics and so on. So as I said, it is just this whatever platform that I showing here is just the start, and we are actually growing to support multiple layer interoperability, which is actually important in the growth of smart, sustainable city in the future. All right, I think, yeah, so that is all I have for today. I think it's almost 15 minutes now, I think, plus. So yeah, so I'll take any questions.
Okay, thank you very much, Dr. Gopi. So let's open to the floor for any question and answers for the next 5 minutes. I saw one question here from the FB Live from Dr. CY. She mentioned that, the question is, who should lead the smart city initiatives? Is it the government or is it private lead? Because we observe lots of smart city pocket initiative, yet no sign of a city in Malaysia can be labeled a smart city. So how can we scale up? I mean, to be fair, there are smart cities in Malaysia. Okay, maybe Dr. Gopi would like to share something about this.
Yeah, I think see, the owner of smart city is usually the government or the local councils and so on. Now, even okay, so we take it like this. It should be the drive should come from the stakeholders themselves, because they are the owner, they are going to operate it. But of course, they cannot materialize it without the help of all the local players or any private organization. And there must be a win-win situation. You see, most of the time what we see is that, of course, government have limited funding. They cannot fund all the use cases in smart cities. There must be a way for vendors to go in, right? So open up the platform for those to come in and provide the solution. And maybe later on, there must be a way for them to also get revenue. It's not that, it's kind of a POC and then die off after that. But the thing is that the initiative should come from the stakeholder, the owner of the smart city project. I mean, that's my take.
Yeah, I think it's true in many cases that the actual stakeholder in the whole smart city, actually the city themselves. So the local authority will have that, say in terms of, when they embark on this project, they require the partnership between the private and also the public partnership together with them in order for them to deploy that kind of solutions. But Dr. Gopi, I understand that there are this new initiative that's trying to work out to ensure that when we embark on smart city, there must be tenders like this, sometimes getting confused by many vendors because they come in with different standards and it's getting confusing. So we heard that the government is working towards one standard smart city framework. Can you share a little bit on that? What is the status now?
Yeah, thanks, Dr. Mazlan. I think at two levels. One is at the Technical Standard Forum, which is under MTSFB. The other one is the under the Malaysian standard. Now, what we are doing is that coming up with the standard framework that could be applied by anyone to want to implement. Now, the purpose is simple. You see, like what Dr. Mazlan mentioned. Yes, each time when we wanted to deploy a smart city solution, there'll be various kinds of standards or documents are being used. There's no one common standard, and every time a vendor want to come in and propose a solution, they need to adopt to the different kind of standard. The purpose of this particular document is to standardize everything and follow that so that it'll be easier to interoperate in the future. So currently, I would say the particular document, I would say about 50% complete, and hopefully in the next few months, we should complete and present it to the committee for the endorsement. And again, there's not that it will be enforced to be used. It is up for the stakeholders to freely use this document so that it could have a common understanding, a common interoperability with various vendors and application providers. That's the purpose of it. We cannot force them to use it. So this is a voluntary standard actually.
So in the case that there are companies which are very interested to join and participate in this kind of initiative, what's the process for joining this kind of work?
Yeah, so what we do is, at the Malaysian Technical Standard Forum, so anyone can actually freely join. So they can go to mtsfb.org.my. They can get more information about how to join and so on. They can join either for a subscription, or they can freely join just to contribute any information or anything that they need to be included in any specific standard document. That's one way of doing that.
Okay. So thank you very much. I don't see any other questions. So you hang on first until the end of the session, so that maybe if we have more time, we can open up for general open questions later.
Yeah,
so
sure. Thank you.
Dr. Gopi, thanks for the presentation. So for the next presentation, we have someone from overseas. So we are lucky enough to get our speaker from Turkey. Yeah. So what we have, I think the timing today maybe is very good over there. So it's very good morning to Mr. Fatih and Mr. Murat. So these speakers are from KoçSistem. So one of them is Mr. Fatih Suluner. He's the head of international. And we have another speaker, Mr. Murat Koncuk, is also an IoT industry leader. So I don't have the biodata, but maybe you can introduce yourself a little bit more between you, Mr. Fatih and Mr. Murat, and your company. So, but we also would like to welcome you to Myota. Thank you.
Thank you very much, Dr. Mazlan and everybody, and Selamat Petang for everybody for listening us. I will make a very short introduction of Koç Holding and KoçSistem in 3-4 minutes. And then I will give the floor to my colleague, Mr. Murat Koncuk. So let me quickly share the screen, please. I hope you are able to see it, right?
Yes.
Okay. Let me start, Dr. Mazlan. Koç Holding is the largest enterprise in Turkey and the only Turkish company in Fortune 500 globally. Almost more than $25 billion per year revenue we are making with the number of close to 100,000 employees. We do total, 9% of total export of Turkey and 8% of total GDP of Turkey. So it's a giant holding group. And as KoçSistem, we are the technology leg of the group, with more than 1,500 employees, a lot of customers, including overseas ones. And we have a lot of partnerships such as Apple, Dell, Microsoft, Huawei, you name it, like all system integration and technology companies. We are also the first SoC operator in Turkey with more than nowadays 60 customers, and half of them are multinational companies. We are a data center operator, and we run 3 data centers, and we do have a lot of other services. What we do outside of Turkey, we transform the business into the technological way in more than 30 plus countries. We have also some references in Malaysia, but this is another day's topic, so I will pass through. And the main industries we are active are the finance, insurance, public retail, energy, manufacturing, automotive, and telco. So in all of those industries, we can provide our solutions in order to help their digitalization journey. Very quickly about Koç Digital, which Mr. Koncuk will explain you better than myself. We, together with Boston Consulting Group, we start our operation named as Koç Digital, belong to KoçSistem, which is focusing pure analytics and digitalization projects worldwide. And then we established some of good references, worldwide known names such as Abbas, such as Ford, such as Fiat, and we are using a lot of capabilities within our Koç Digital organization. So thank you very much for my time. Another session we can plan for introduce you the KoçSistem. Now, please, thank you very much for listening to me, giving me the opportunity, and I leave the floor to my esteemed colleague, Mr. Murat.
Thank you very much, Fatih. And can you see my screen?
Yes.
Okay. But I am Murat Koncuk, and I am working as a IoT industrial leader at Koç Digital. And Fatih mentioned that the Koç Digital, but I would like to just give you a summary. Koç Digital is a IoT and analytics spin-off from KoçSistem, and which is the market leader system integrator. And Koç Digital actually was founded with help of BCG, Boston Consulting Group, in build, operate, and transfer model 3 years ago. And as you see, we have more than 200 people, 200 employees, and they are just focusing on the IoT and analytics, Internet of Things and analytics. And we have PhDs, for example, and that PhD is about the predictive maintenance, predictive quality, demand forecasting, or so on. So you can see more than 200 people just focusing on the IoT and analytics. But today I will not give about the technical details. Just I will give I will talk about how we transform our customer, how we transform our business. Normally, this I think you know this chart, and you are very familiar that if you would like to transform your business, if you would like to do anything else about the Industry 4.0, first of all, you need to provide your business to the transparency. Actually, you need to collect the data. After that, after you collect the data, you should actually do predict. And for example, you can do, it depends on your business, you can do predict the maintenance, you can do predictive quality or optimization, something like that. Collect the data, predict your business, then it will be a self-optimization. But normally, like the legacy IT skills, you cannot do that. It's not so easy. So if you want to do an Industry 4.0, any project, first of all, actually, you need to collect the data, as I said. But when you collect the data, you need to know about the PLC programming, you need to know about the sensor installation, you need to know about the the gateways actually. And then if for example, okay, you know about the hardware and you know about the sensor, then you need to collect the data to an industrial IoT platform. And that IoT platform should have capabilities, device management, integration, data analytics, and so on. Okay, you collected, the hardware, you collect the data to the IoT platform, then you need to run an application on your IoT platform. It depends on which kind of application. It depends on your business. It can be asset management, it can be a worker assistant, energy monitoring, or digital mining. Okay, we collect the data to the platform, then run an application, but the most beneficial things actually run or do analytic projects, and it can be a Industry 4.0 assessment, predictive maintenance, video analytics, and so on. But of course, when you are doing that, you need to consider about the OT security, and you need to consider about the network and the network, the protocols, Wi-Fi or other things. And of course, these IoT and analytics application is a huge and giant application, so you need the many services. And you cannot do all of them is alone, you need a partner ecosystem. So as a KoçDigital, actually the KoçDigital can do that, all of them. So when we are doing an IoT project or when we are doing an analytic project, we are end-to-end on the IoT company, and we have an IoT platform, and we have a radio application, and we have a advanced analytics solution, and we are not producing any hardware, but we have a hardware team, and they advise some hardware, and they know about the PLC programming. So when we are doing any project, any IoT and analytic project, KoçDigital is your just you are talking with the KoçDigital. Of course, this is good word, but what we have done in Turkey or what we have done in the world, actually, we have done the largest IoT project in Turkey, and I will give details, my other, the slides, and it's more than 500 sensors we connected to a single plant for end-to-end transparency. And we are not just working on the manufacturing, we are also working on the digital mining. We are not working on the mining. And we have the digital mining platform, and we are optimizing the mining, and we are, monitor, and we are manage the mining, actually. And we are not working on just in Turkey. We have project at the East Europe, we have project Africa, and we have project the Middle East, actually. And we are not just, we have also, connected the service. We are connecting the cars, we are connecting the electrical vehicle, charging station, and the connected welding product. So I will give more details about these customers, actually, stories. So one of them is one of the biggest one is the Ford Otosan, the Ford, I think, and Ford has 3 factories in Turkey, and they are manufacturing Ford Transit, Ford Tornado, F-Max, and the vehicle engine. Before our project, actually, Ford calculates their KPIs, root causes, downtime manually. And then they would like to digitalize their asset performance and KPIs and alarms. And also, I think the industry guys know that mean time to between failure, mean time to repair, and they would like to digitalize that. So we collect more than 3,000 connected assets, and now they are actually they are monitoring their factories in a digital TV. And after this project, as a result, they gain more than 6% capacities, and their manufacturing, their maintenance operation actually efficiency by 30%. And how we do that? Actually, we have a manufacturing information system. It's a built-in actually manufacturing. It's a built-in MIS system, and it's there are a lot of reports, and there are a lot of screen, and there are a lot of dashboards, and you can, as you see, there are asset performance reports and cycle analyze, bottleneck analyze, OE analyze, and the downtime root cause analysis. Of course, as I said, we are not just working on the manufacturing, we are also working on the mining part. And in a mining, the Demir Export is the leading mining company in Turkey. And in a mining, we collect more than actually 7,000 assets, and they are crushing, grading, bands, pumps, and the industrial vehicles. We collected the data, and we are actually done a digital TV mining. And how we do that? We have a digital mining solution, and it's also ready to deploy. And we are managing the equipment in that mining solution, and we have a production management. We can do asset management and ERP integration. We can do the worker management, indoor RTLS or safety part. So as you see, we have done many mining projects, and not just manufacturing, not just mining. Also, we have a smart city actually solution. So we have done out of Turkey. This reference is out of Turkey, and we have done a smart city solution, smart city project, and we are collecting the data from the towers, from cameras, and from the sensors. And that's with this project, we can monitor camera conditions, and we can monitor the power supply status, temperatures, and also we can do the security part. So after these, our solution, our customer decrease their unplanned downtime, and they are just monitoring in one screen, and they can see all towers and all cameras. And the other are, the remote asset management project is the Abbas. We have done a connected car project. It's not just, the connecting car. We are also do connected car and connected rental, actually connected car rental. And the customer now use a mobile phone and rent a car, and they unlock the car, and they start the engine with their mobile phone. So after this project, our customers can, the active user account increase more than 200% actually, and average their reservation increase by, the 300%. So we have done this project actually with our platform. Of course, there are a lot of different kind of project, and we work on the durable part, we work on the, a welding machine part, or we work on the, the BSH, for example, all of them. We work on the municipalities. So our platform actually has a vertical solutions, and you can collect the data in an industry IoT platform. Then you can use all of them. For example, we used in Ford manufacturing information system. Then we are now working on with the Ford Otosan for the predictive maintenance part. We have used worker guidance in actually in a durable company, and we are now using the RTLS, actually RTLS and manufacturing traceability for the AGV. The AGV automated guided vehicle actually. So our main idea actually collect the data in a platform, then use the vertical. So as I said, in IoT project, the main challenge is collecting the data. So we have a hardware team, and we know the hardwares, and we know how to collect the data. So we collect the data from industrial robot, AGVs, manufacturing tools, PLCs, construction equipment. So we have a lot of experience, more than 300 equipment types. So we can provide this solution from on-prem, hybrid, or on cloud. Actually, as a result, this is my last presentation, the last slide. As a result, with KoçDigital, actually, you can do your IoT journey, or we can say it's the Industry 4.0 journey. From planning, we are doing the assessment, the Industry 4.0 health check assessment with BCG or with other companies, and the connectivity. I mentioned about that. After connect the data, we can do the real-time monitoring, and after that, the operational predictive system. All of them is ready to deploy to the KoçDigital with the KoçDigital. Thank you very much.
Thank you, Mr. Murat and Fatih, for the very good presentation. And this is our first time to listen to someone from overseas to to showcase their products and services, which I found out is very you have a very huge company, and as a system integrator with a lot of projects and assets that have already been connected. So I think for the rest of the members here and the audience who wish to ask questions directly, you can raise your hand and we can unmute you and you can talk directly, or you can put your questions in the chat box. So either through here in Zoom or also in Facebook Live. Okay, let me ask you a little bit more questions about KoçSistem. I love the way that you guys have been transforming the industry over there, and there are various examples from mining, smart city, and also manufacturing. In your experience over there, how long does it take for you to deliver that kind of project with the numbers of assets that be connected? Does it take you about 3-6 months, or I'm not sure. How long does it take for you to complete?
Actually, it depends on, you know, the asset types, and it depends on the, you know, the technology part. For example, if you are doing a project at the green factories, for example, in a green factories, you know, you are establishing a new factory, it can be 3 months. But it's a brown factories, and there are, for example, there are PLCs or there are machines more than 30 years. So the connection will be hard actually. So it depends on the assets size, it depends on the, you know, the asset type, it depends on the asset age, and of course the, you know, the what you want to do. You are just you want, if you want to just, you know, the monitor, it can be 6 months. But if you would like to do an analytic part, predictive maintenance, predictive quality, you should collect the data and you should wait actually. So it can be 1 year. And it depends on, for example, we are in the mining companies, we have worked, it's if third phase takes actually 6 months. It's open mining, but you know, the underground mining, it's not easier than, and the mining, you know, it's like a like, how can I say, like a life that they are living actually. Today you have just, for example, that way, and the way the road is changing, and you need to, you know, change your mind, and you need to collect any tower or something like that. So it depends on mining part and mining assets actually.
So when you mentioned about the mining use case scenario, the sensors are underground or above ground?
Both of them actually, not just underground. We are collecting the data from the vehicles, from excavators, and, you know, from the trucks, and also we are collecting the data, you know, some machines underground. So of course, yeah, of course, it's, for example, for the shape underground part, we are using the LoRa or some, or the other, you know, technologies. But for example, for the other parts, we are using Wi-Fi, or, you know, the private LTE or something like that. So
yeah, something which I would like to, you know, ask you just now, what kind of connectivity options that you have been using in that kind of scenario? You're saying that you're using LoRa, and also
we are using LoRa, we are using private LTE, we are using Wi-Fi, and, you know, we have construct a Wi-Fi tower, for example, and it's like a, you know, with a wheel. So we are using Zigbee. It depends on as I'm saying, it depends on the, you know, use cases, it depends on the situations. But private LTE, wireless, and the LoRa we have done.
In Malaysia, recently we just launched our 5G network. Are you ready in Turkey to operate on 5G too?
5G, we are, you know, we are working with the operators actually. We are ready, not, you know, all over the world.
Okay. Just one last question. You just now on the last slide, you show the different verticals, the players. Are they your partners, or the people who are the device that you connect to, or are they their partners? Are they your partners too?
Our partners, one of them is our partners actually. Well, some of them is our partners, some of them are not our partners, but we are working with them.
Okay. Because you are as a system integrator.
Yeah, we are system integrator, because, you know, the KoçSistem is the biggest system integrator in Turkey. So we are, KoçDigital is just, you know, we are just focusing on the IoT and analytics. For example, in KoçDigital, there are no any employee about the HR, for example. We are just, you know, the HR is from KoçSistem. So more than 200 people just focusing on the IoT and analytics. The technical guys, and for example, I am the industry leader for IoT. There are another people industry leader for, you know, the mining, another people industry leader for the analytics at the automotive sector. So we are just focusing on that part. So we are using the KoçSistem power actually.
How about the hardware themselves? You get this, you source this from the local, or you have, you know, someone that you outsource it from overseas too?
We are using for hardware part. You
yeah, the hardware, the sensors themselves.
Yeah, Actually, for KoçSistem, for Koç Digital, we are not producing any hardware.
Yeah.
We are using partners in Turkey, all over the world, not just Turkey, all over the world. We have partners with the hardware part. For example, we are working with, the Cisco. We are working with Nokia. We are working with another hardware companies.
Okay. So thank you very much. I don't see any more questions. But I would like to say thank you, Mr. Fatih and Mr. Murat, for your presentation. Hold on until the end of the presentation so that maybe we can have another chat or another question and answers in general. Thank you once again. Thanks.
Thank you very much.
Thank you.
Okay, so now we are on the third session, third slot, third speaker. So we have our third speaker is Mr. Prabodh Sheth. So let me slightly brief about his biodata. Mr. Prabodh is actually currently the CEO of iCEE International, an energy savings and services company. He drives all the corporate strategies and sales initiative, especially investor relations, fund management, and product commercialization. So under his leadership, iCEE has been a global energy efficiency category winner in San Francisco in 2017, and also nominated by Digitality 50 as one of the technologies that actually will shape Malaysia's digital economy in 2018. And also he had obtained a grant from Platform and now currently in Series A level investment round. Wow, congrats, Prabodh. Okay, Series A.
Thank you.
Soon to be a unicorn too. All right. So I think without further ado, I'd like to invite Mr. Prabodh to speak on this topic. Thank you very much. Prabodh.
Hi, good afternoon, everybody. Let me just do a quick test check. Dr. Mazlan, can everybody hear me clearly?
Yes, slightly echo, but I'm okay.
All right. Let me see if I can, because I'm in a meeting room at a client's place, so no worries. Share my slide. Okay, so I presume you can see my slide, yeah?
Yes, please continue.
Is that yes?
Yes, please continue.
Okay, so good afternoon again, one more time, everybody. Thank you, Dr. Mazlan and my IoTA Association to give me this opportunity to speak. I appreciate that very much. I will spend about 10 minutes discussing the topic that is today. And then I believe there is a 5-minute Q&A session also. So the topic that I'm covering today is smart buildings with autonomous operations. And I intend to specifically talk about something that we also have in place, but more generic in terms of the overall activities related to autonomous operations. However, before I talk about smart buildings and autonomous operations, I believe that I want to make a small clarification, which is that renewable energy is not energy efficiency. And the reason why I'm making this clarification is because it relates to the topic that we are going to discuss today. And basically, energy efficiency is about reducing consumption, whereas renewable energy is about alternative sources of energy, such as solar, biomass, biodiesel, and the likes of it. So why I make this clarification is that a lot of times people mix up the two between renewable energy and energy efficiency. And iCEE, the company that I represent, specifically is in the field of reducing energy consumption rather than in the field of providing alternative energy. And this is where I believe that a high level of autonomous controls and methodologies can be deployed in order to get best results. So while there is a global initiative on green technology and energy reduction, there has to be a lot of focus on energy efficiency and energy efficiency methods. And one of the best ways to achieve efficiency is naturally to go towards some level of autonomous controls. Yeah. So according to the World Economic Forum, smart city applications comprise of sensors, networks, and engagement. In fact, a lot of organizations are coming up with digital nervous systems or digital operational centers or unified operation centers for the purpose of providing such smart city applications. And I believe that one of the biggest components in a smart city is a building. You know, if you look at any city comprises of a lot of buildings. There are hundreds and hundreds of buildings in every city. And if you get the buildings to become smart, or if you have smart buildings, then you will have quite a huge group or a huge component of your smart city applications addressed. Yeah. So, and in the same light, the business opportunity is also a very significant opportunity for the people who in this group that are reseller communities or distributor communities. There is huge amounts of investments going in because there is a significant need to reduce energy consumption. The cost of energy is going higher and higher, and the utilization of fossil-based energies or fossil-based fuels is going to become more and more penalized, and therefore rising the cost even further. So moving towards the specific topic that I'm speaking today. So autonomous solutions with unified operational centers. So if you look at what is happening in a building and all the different areas of the building, then specifically my focus here is that how are we able to improve the efficiency of the building, and how are we able to achieve autonomous operations, and with the end game that literally speaking, it is like a self-driving building which is able to diagnose itself, which is able to initiate job tickets, and which is able to get maintenance through to go and fix the component or the part that is not operating perfectly. In the same light, you also have activities such as indoor air quality, air conditioning, and various other activities that happen in the building in the background on a regular basis, 24/7, if the building is a 24/7 building, in which case then you need to deploy sensors or some form of ground level controls that will allow you to identify what is going on in the building. So if you look at autonomous operations globally, you have building automation which is actually controlling all or a good portion of the equipment and the machinery or appliances, as the case may be, depending on whether it's a commercial building or an industrial building. Then the second level is optimization. So first step of automation is the step related to looking at how the components are being controlled, managed. The second step of optimization is to take it one step further and look at how you can improve the operational efficiency or improve the operations of the building as opposed to managing or controlling the unit. Yeah. The third step is the data analytics, so that you can go into predictive maintenance components. So data analytics, there are huge areas of AI now, digital nervous networks and neural systems, and a variety of them, to come up with how you are able to identify historical trends or predict future activities or future trends, so that you will be able to understand the building better and get a better overall result. A lot of you might have heard of this term, data-driven decision making. So when you look at predictive maintenance activity, and the most critical one, I think today is condition-based maintenance, where instead of doing a frequency-based maintenance, such as an annual or biannual or quarterly maintenance activity, you actually look at utilization, consumption, or any other operational parameter that will allow you to spread the maintenance ratio or the frequency of maintenance and thus reduce the cost. But that also will allow you to monitor the activity of the unit, and you might find that you actually don't need to maintain it for a very, very long time, because once you have statistics of each maintenance cycle, you will be able to determine how often you actually need to do the maintenance in the first place. Of course, in order to achieve a lot of these activities, you will need to have integration points, and integration points again become very critical, because especially where you have a building that has been aged, you find that there is a lot of equipment that might not be integratable. So what we have done is to build devices or to build intelligent methods of getting the data from that equipment. And in a worst case scenario, of course, we might have to replace the equipment. But equipment integration points are very critical, both from a SCADA perspective in terms of building automation and building controls, but also from looking at how that can be then translated into data for further analytics and applications. And finally, energy monitoring. So energy monitoring, again, is an activity related to the whole building, and the biggest consumer in a building typically of energy is your central air conditioning, specifically the huge chillers that are residing in the basements of many of the buildings. Central air conditioning will typically take up anywhere from 60 to 65% of the total consumption of a building, and of which the chiller alone can take up 2/3 of that. So it's a very, very significant event if you are able to control your chiller. You're able to reduce energy on your chillers, and more benefit you will derive is if you are able to run your chillers autonomously without human intervention, thereby bringing your facility management costs down also. If you look at a unified operation center, this is a chart from Aviva. You will find that, for smart cities, they are pushing towards unified operation centers, which allow you to look at all your aspects of your city. And I believe that a unified operation center is what is required in the case of a building also, so that you will be able to have your building running and you will know what is going on in your building. And oftentimes, especially buildings that are not brand new today, oftentimes they are at a flux or a change situation where they are not able to incorporate a lot of these new technologies because of the fact that they are already invested in existing or older technologies. Okay, so as a result of that, what we have done is that we've developed an intelligent algorithm which will basically allow you to install almost seamlessly. We are moving now towards wireless installations so that you can have quick installations and quick estimations. But most importantly, the only thing that the building needs, or the building management needs to do, is to install the system. Thereafter, the system will do everything, including controlling the chillers. So the chillers will run without human intervention from the point of data gathering all the way to the point of the demand limit controls. Why I'm giving this example is that this is one of the ways to have autonomous operations within a building, so that the building itself is able to run itself, and the building is able to then cure itself, whereby the second step of autonomous operations is to take this existing information and then run it through a either a neural network or a smart algorithm, so that you are able to get trending and historical information. And the third step is to be integrated to service providers. So when you're integrated to service providers, you will be able to initiate a job request or a job ticket in order for you to come in and fix and therefore reduce again your maintenance costs. Some of the features, let me move my picture. Some of the features I want to run through quickly. First is wireless sensors. Wireless sensors allow you to have a lot of flexibility and the number of nodes and points that you have, as opposed to wired sensors, and the cost involved, especially in advanced development countries. The second is in the field of big data analytics. Big data analytics will allow us to take all of this data from the sensors that we have installed and create a digital twin. By creating a digital twin, you will be able to then view what is going on in your plant without having to physically go there every single time. The third is to incorporate AI, which is the predictive maintenance and analytics that I spoke about earlier, where you allow yourself to go into different types of neural network applications so that you can identify trends. You can even have predictive algorithms running the system. The fourth, of course, is cloud computing. Cloud computing has changed a lot of things and a lot of things about the way we do things. But most importantly, I think that cloud computing allows you to do away with reliance on manpower, skill, and technicians on the ground. Organizations like Amazon Web Services or AWS have a whole slew of platform and solutions, both in relation to authentication, management, utilization, and also development, application, and deployment, which really takes a lot of the pain and the problems of on-site or on-premise solutioning. And finally, augmented reality. So AR and VR are two very exciting areas in terms of how we are going to be able to view things and how we are going to be able to address things. By having the smart goggles, the technician will be able to see exactly information about what is the equipment he's facing. Say, for example, he's looking at a chiller, he'll be able to see the year of installation, the date of installation, when was the last maintenance done, what were the number of trips that have happened in the chiller in the last 5 years, you know, and a whole slew of other parameters such as what were the operating hours, etc., to quickly zero in on what could be the pain or the problem that he's facing. So augmented reality, other than exciting movies, is going to be something that is going to change our lives and the way we do things. So just a quick on the solution before I end my topic today, which is that iCEE as a whole basically is a chiller optimization specific solution for central air conditioning. We are taking that one single vertical of smart buildings and then having autonomous control, aka self-driving central air conditioning systems. The benefits, of course, is that you will go down the path of digital transformation. Most importantly, you save energy and prolong asset life. Your maintenance management will be significantly improved. There is a potential for reduction of manpower or redeployment of manpower into better areas. It's a highly scalable activity, and of course, you reduce your CO2 footprint. What is important here, I think, is not just about what our solution is, but I think as a whole, we believe that if you adopt smart building solutions, especially autonomous operational solutions, you will derive these benefits across the board for the entire organization. So I just had the same chart earlier, except that a little bit of marketing here on iCEE, which is that smart city applications start with smart buildings, and iCEE is one of the verticals that could bring you to that direction. So with that, I thank my IoT, everybody that has been listening and opening up for questions.
Thank you very much, Prabodh, for a very excellent talk on this topic of chiller management and all that. utilization and optimization. So for the rest of the members who are the audience here, if you want to leave your comment or your questions, you can leave in the chat session, or you can also raise your hands and we will unmute you for to have a direct talk. But again, I think iCEE is a solutions or technology provider. Do you work directly with the customer, or you work together with the facility management in providing that solution?
We work both. We work directly with the customer. We work directly with the facility management. I guess it really depends on the engagement. Like say, for example, in certain scenarios, we have to look and find out who is the person in charge of the cost. Siapa yang bayar bill tu, right? In other words, the person who is paying the bill is the person who is going to be most motivated to implement autonomous solution or energy reduction or cost reduction system.
Mm-hmm. So when you look at these two markets, I see two markets, either the private building or the public building. Which market in Malaysia that you see is most easy to build?
Our focus today is public, or rather commercial buildings, I should say, commercial and industrial buildings. Yeah. So let's just do the differentiation instead of private and public, meaning that government and non-government.
Yeah.
I draw the line between residential, commercial, industrial.
So which one is the biggest market?
The biggest is commercial, industrial.
Commercial, industrial, yeah.
Yeah, and within the commercial and industrial space, the biggest ones are your 14 hours and above operating buildings, such as mall, airport, hospitals, hotels, and manufacturing organizations.
Just now you did mention, I forgot, I didn't hear a little bit more about how many % of cost saving that, once you implement the solution?
Once you implement the solution, you should be seeing between 15 to 20% of your energy reduction on your central air conditioning costs. For some reason, Dr. Mazlan, I can't hear you.
Okay, sorry. When we look at this kind of building, this either the brownfield or the greenfield, the new or the old one. What are the main challenges that you face when you deploy this kind of two areas of building? Yeah.
Well, I mean, the most obvious challenge is the state of maintenance of the equipment, right? So while you can install the same system in two exactly the same buildings, even side by side, the level of maintenance of the equipment will drive the efficiency of the operating equipment there, right? So you might have two different efficiencies. The chiller plant efficiency might be different as a result of the level of maintenance. That's number one. The second challenge, of course, is that you often have sharing of bills that are based on some form of physical parameter. Misal kata joint management board between the mall and the residential towers. Let's say you have a building with two towers, right? One residential, one commercial, and the ratio of sharing is on the base of square feet, right? Or some similar ratio, and then adjusted for maintenance costs. So typically the residential tower will be paying to the commercial tower because the commercial tower is where the building management resides, right? So the cost of managing the building plus the electricity, some form of a ratio is determined. And when such a ratio is determined, if you install an energy saving device such as ours, you have a problem in allocating the savings using that same ratio, because that ratio is skewed towards including maintenance costs. Yeah, that's second. Third is, yeah, I mean, I can go on forever, but I mean, just let me give you the three big ones, right? The third one is, of course, that typically when you go into a building, you need to make an assessment of the potential for saving, and how well you do that assessment will be a big determinant of the success of your eventual installation.
Wow.
So these are the, I think, 3 challenges. I can give you 10 more, but let me just stop here.
If too many challenges also, it's going to be very difficult.
That's right.
Okay, so thank you very much, Prabodh. I think we're short of time, so thank you for your presentation and for the question and answers. Please hold on to the end if you can have time. Maybe you can have some wrap-up session later. Yeah.
Yeah. Okay.
Okay. Thank you, Prabodh.
Bye, guys. Take care. Thanks again.
So now we have to our last speaker. The fourth speaker will be on benefits of implementing real-time OEE with industrial IoT formulation manufacturer. Will be presenting by Has Integrated Sinniah Murat. So there will be 2 speakers here, Harun, Aziz, and Edmund. So I got the Mr. Harun's profile. He is quite an experienced person, 25 years in the automotive engineering related industries. He graduated as a Bachelor of Science in Mechanical Engineering. He started his career in Proton and then GM Holden. He has also worked for Petronas Motorsport and now served as a Managing Director for Has Integrated. So he has served as a technical consultant in various engineering projects from vehicle development to oil and gas. Currently, Has is focused on industrial data operations for advancing manufacturing on digital transformation. So with that, I would like to invite Mr. Harun for the speech and also Mr. Edmund. Thank you. Cannot hear you.
Encik Harun, you're muted.
Okay.
Ah,
All right. Can you hear me now?
now, yes.
Okay. We are focusing more on industrial data ops. Basically, there's a very good analogy by Dr. Nicholas last month from UTHM. Industry Revolution 4.0 is producing a lot of raw data, but these raw data are unusable unless processed. So it's like crude oil. You need to send it to the refinery before you can actually send it to the petrol station as petrol or diesel or some other products that they use. We also have our solution partners, HiByte, AUK, and NXT. And I will pass to Mr. Edmund shortly, but briefly on the HiByte Intelligence Hub. These are the refinery that you need for the raw data before you pass it on to your analytics platform or for your ERP or whichever software that you want to pass it through. And this is using the unified namespace, which means that it's a publish and subscribe model, spoke and hub model, which is, we believe is one of the most efficient platform available out there. And it's codeless, it's pretty lightweight, it's web-based, and it's flexible, it's edge native, and also it's edge driven. So if you add on new sensors, it will just auto-detect and add the sensors and publish the relevant data that is typically published by that type of sensor. All right, I will pass to Mr. Edmund to talk specifically on the hardware side, which is because a lot of machines are legacy machines. I mean, these are old machines. Sometimes they don't even have PLCs that can communicate with our software or with the other software that we need. So we have to find a workaround to use these legacy machines and to extract data from them. So I'll pass to Mr. Edmund.
Thank you, Harun. Thank you, Dr. Mazlan. Right, sure. So maybe I will share my screen first. All right. Okay. Okay. Are you guys able to see my screen just to confirm? Okay.
Yep.
All right, great. So yeah, thanks for having me. We are actually together with Has Integrated. They are our integrated partner. I'm actually Edmund here from Org Industries. So I take care of the Malaysian market. Very much into IoT solution. So Has Integrated, as I will quickly go through a little bit about it. But before I start, because we want to really focus on the topic of the benefits that the Malaysian manufacturer can get out of IoT, instead of product introduction too much. Of course, I will still go through a little bit what are the offering that we can give you in order to ease the way and the path for you to implement a smart factory. So a quick introduction. Basically, I'm not sure whether my screen is blocked by some of the panel, but okay. So basically, our solution comes from Singapore. It's actually made and developed there. And at the moment, we have across 7 countries, mostly in Southeast Asia. We have 1 in Europe and 1 in US. The rest is very much in Southeast Asia. So we really focus on the operation here. As you know, there are many legacy machines. I would say the ratio in the Southeast Asia new and legacy machine can be somewhere between 60% are old, 40% are new. Some companies are even higher. So there is a very strong need to have a plug and play device that can get data without going through painful integration with the PLC, where some of the machine makers are not even available anymore. So at this point, we have 2,800 machines connected. Of course, different sizes of companies. Some company have 10 machines, some company have 50, some even have 100. Yeah, different sector industry. I'll show you why we could do that. And basically 90 factories running with our operation at the moment. Okay, these are some of the client base that we have. You can have a look here. I think I would say 30 or 40% of them are actually Malaysian based, because we have started this about 4 years ago, in very much into the manufacturing industry. And here, this is actually a partnership with McKinsey in Singapore. They even brought our solution all the way to Europe to actually showcase to the manufacturers there, so that they can really deploy this system into their platform, into their factory. Right. So as I mentioned, as I promised, it will be very much about the benefits of the manufacturer rather than a commercial kind of introduction. So here, we straight go to the point that we wanted to show you the possibility of this industrial IoT. Once you connected with the industrial IoT, basically all the machine that you have will become individual tiles on the software. And what we could actually track is all these little breakdown of losses. Okay, conventionally, for a company to be able to produce 1 million pieces, that is with 365 days, God-given time, but you always have all kinds of losses that is punishing you, and probably by the end of the year, the output could be from 1 million parts go down to 400,000. But where are the losses? These are typically very difficult to be identified. Therefore, we need this kind of device. You cannot be asking the operator or the engineer to copy the data from the machine every 10 minutes. It doesn't make sense. Typically, I see the most frequent company will do it probably 30 minutes. But even that, there's so many small losses that you can't capture. So but with this device, one is real time. We get our data from the machine directly without any human input. What we could see is, for example, when this machine is running, when the machine is actually planned for downtime maintenance, when is it doing a changeover, when was it breakdown, and minor stop. These are the stops that is actually less than 10 minutes. For example, every 5 minutes, we have a client who have a 1 minute stop because of the fluctuation of the air compressor that causes the production line to have this small jam, and then the operator have to do something about it. So all this is actually minor stop that we can capture as well. You can imagine every 5 minutes, if I have a 1 minute stop, that is almost 20% of losses. Then we have street loss. If you have 100 pieces that you can produce in a minute, the next minute you are producing only 80 pieces, that is also a loss that we can capture. And of course, reject and rework. Yeah, so here, this is actually from McKinsey as well. That's how they define OEE in terms of the 3 buckets. Some of you here are already experts, so I wouldn't want to go too details about it. But now you have this overview. Let's go into how we can help you to track this. All right, go next slide. So we really developed this hardware and also software complete solution. Our software is very much on the analytics of our data only. And then of course, I'll share with you a little bit how HAS integrated help us to integrate with other software like ERP, MES solution. So here, the concept is actually a plug and play device. The fastest that we ever deployed for a client in Malaysia, it took us 2 weeks. 2 weeks to complete 10 machines with a gateway. So everything is wireless. So we do not need extra cost for the infrastructure where you need to lay cables around all your machines, because some machines are really old. It doesn't have even the Ethernet port and things like that. So you can imagine this is actually each of our IoT device. I'll share with you how this IoT device can read data from here. We are reading raw data, sensor data, temperature, pressure, counting sensor, and so on. So you can imagine each device has an IoT node, we call it. And with the IoT node, it actually sends the signal via wireless mesh all the way to the gateway, and the gateway is connected with the production office LAN cable, and then it will send the data to cloud, and it will be processed and provide you the insight. Over here is still very much raw data. Only when it goes to the cloud base, then you have the insight of the machine and speed loss and all the interpreted data. Okay. So I guess I will leave the question later so that I can go through it in a 15 minutes time span. Yeah, so you can keep your question later to share with me. So the wireless mesh network is allowed us to have the distance between each machine 200 meters to 300 meters, depending on how many walls in between. When I mentioned 200-300 meters, that is inclusive of walls, and this device is enclosed in the machine cabinet. So that is considered. So if it's open space, we can go as far as 1 kilometer. Okay. So all the data is timestamped. That means every time when I receive a counting, 1 pieces, 2 pieces, these data are timestamped. I know exactly when the time was recorded, this sensor, and go to the gateway, and the gateway will fill in into the software. Even without internet, we have storage here that we can keep it here for up to 64 days. As long as any of the days that you have internet, it will backfill into the software. Okay. We use actually Google Enterprise for our cloud platform, which is ISO certified, as well as all the backups that's necessary. Okay, let me go next. Here, some example for you. With the wireless mesh, you can imagine, even for big facilities, they will feel very much convenient because they don't have to lay cable. You can imagine these are large size factories. So they have one end to the other end of production line, some tanks, some silos, some controls. Yeah, with the mesh capability, we can really go very far because each of these nodes, we can hop up to 64 times, 64. So 200 to 300 meters between them. If this is 600 meters away, the data will be collected here, hop to another node, hop to again, and all the way find a path to the gateway. We also have an algorithm that even if some of the machine is not turned on, it will find other paths to hop back to the gateway. Okay. I'll go through. So this is the part where HAS integrator work very closely with us. As you know, in the market, in the enterprise solution, there were so many software and we can't do everything. We are only good at what we do, which is the industrial machine data. Other things, planning, we are really not there because our solution is very focused on this alone. So our strength is that regardless of the type of machine that you have, age of the machine that you have, legacy or new, we are able to get the data. I'll share with you in the next slide how we get the data, even though you have different brand, different type. But here, which I want to highlight, which HAS integrator is a very interesting integration solution where they can easily communicate and put the data together and fit into your MES, your ERP, and all the other software here. But today, let's focus on this particular topic. And maybe the next round, we can share more about how the integration works. Okay. So I'm sure by now, most of you have like some kind of smartwatch and all that. It's like a Fitbit for machine, you can call our device. So this is how the device looks like. It's like a mouse size. The antenna itself is pretty long. The reason is because we want to be able to penetrate through the metal enclosures and jump all the way back to the gateway. So I go on. Over here, yeah, this is the part where I really need to spend a little more time to show you why we can get the data. So for example, every machine has definitely, as long as electrical powered machine, you will have sensors, whether it's a relay, whether it's a proximity sensor, contactor, all kinds of sensors over here. So these sensors, for the past 30, 40 years, it always give two particular signal, analog or digital signal. By getting this analog or digital signal, we can connect parallel wiring. That means to say we bypass PLC. We do not actually connect to the PLC. We can connect to the PLC for certain machine, for certain data that we want, for example, like error code and so on. But in the nutshell, if we want to get purely about productivity, those OEE related, we do not need to go into PLC because then we can deploy very quickly. 2 weeks time, 3 weeks time is not an issue. As long as the sensor is available, this sensor we don't add on, we use the existing sensor of the machine. That will be the most accurate. So you can imagine a packaging machine. Every time a packet passes through that proximity sensor, this particular sensor is actually sending data to the PLC. All we need to do is do a parallel wiring. That means to draw the same wiring to our channel 0. Our node itself can connect up to 6 different sensors for the same machine. So you can connect a proximity sensor, a temperature sensor. Of course, we take only the voltage value. So there is some conversion required if the output of the sensor is in ampere. but it's not an issue. It's just a matter of converting the electrical signal. Yeah. So we also have OPC UA and Modbus. This is something that where we talk about if, let's say, a PLC route is necessary, as long as a PLC has an OPC UA or an RS 485 or 232 with a Modbus capability and ProfitNet, it can also communicate with our devices. Yeah, but very much we are pushing over here to get the basic done first, to get the sensor data first. Okay, and it's so simple that even our client, we encourage them in our packages. We actually we will do the demonstration, the deployment training, but they will be the one who connect their machine, because then they know best where is the sensor, because they've been using the machine for so long. They do change the sensor from time to time, so they can do the connection. And sometimes they even change after 6 months. I prefer to see another signal. They can change to another signal of the same machine. Okay, so I want to show you an example. This is one of the clients that we connected. So we need to power up this device, and we draw the power from the PLC control panel. So there will be a lot of 24 VDC that we can find here. We just take one of it to make sure there is common ground. And then we identify from the schematic drawing where is actually the counting sensor. So first we take the counting sensor. It can be different thing. If it's a plastic injection molding, then we take the relay signal. Every time when the mold open and close, packaging, then we take the counting sensor. If it's a mixing tank, then there will be a VFD controller. There will be output analog signal. What is the speed? So the data we get is 0 to 10 volt, but in our software, we can do a conversion. At 10 volt, it means how many RPM. At 5 volt, it means how many RPM. So once it's set, for the user, they doesn't see all this raw data, but they see the actual speed that is running. Okay. Temperature as well. A lot of food manufacturers or even plastic injection companies, temperature data is important to them. We even have a client in Batu Pahat for food manufacturer. They used to be copying a lot of temperature data for their HACCP. Now they don't have to do that. They have all recorded, export them, what time to what time, which date. They have all recorded in the system by real time. Okay. Let's go on to the next. So let's go into the software. So then you can see how it benefits in terms of manufacturing. So here, you can imagine each of these tiles as is actually one machine, and they have this IoT node connected to them. So with the IoT node, each of these tiles is registered in the dashboard. You can see that the whole line, we can even connect them together. Then you get the OEE of the whole line, not just the individual machine. The individual machine, you can double click on it. Then you can see the individual machine in the deep dive. Of course, we also have this patent pending that not just sequential like this. You have this particular machine, but sometimes you have two other machines that is serving one machine. We can set the relationship as it OR gate or AND gate. Yeah, we can go deeper into that as if you are interested later on. Okay, so on top of productivity, we can also apply a current sensor. By using the current sensor, we can measure what is the current flow to the machine. Of course, this is not up to 100% accuracy because it's a very low-cost current sensor, but it's good enough to see the trend. I would say the accuracy, we can go up to about 90% of the accuracy with a digital meter. We can even connect to a digital meter if you want the exact kilowatt hour. But here is for the very first time, you can actually see the data not just from the switchboard, but individual machine consumption. You can imagine if I know during this period from 12 a.m. to 5 a.m., I produce 8,000 units, and the same period of time, I have used this amount of energy. Then you can do actually a trend analysis where I'll show you later our feature. Then you can know how much is the energy consumption that roughly I need for one piece. Yeah. Right. So these are the current sensors that we actually clamp to one of the flowing power supply. Yeah, over here, sorry. So this current transducer is connecting to using one of the channel. We have 6 channels for one device. So you can imagine that you can take temperature, all that, and then you can still take the current measurement. All right. We could also directly get it from the power meter because some client, they doesn't want to do it on the machine. They want to see on their electrical room, and they have a digital meter there. And the digital meter has an output of RS485 Modbus. We just need to have the address. We've done it along with this Micro, which is actually a local Malaysian brand. A lot of factory uses this digital meter. Yeah, we could get the energy consumption at that point. Okay. So all in all, the individual machine, line level, plant level, entity level are all automated because once the sensor is picking up how many parts you produce and so on, we can have this. And depends on the level of the operation in the company. They may be interested only on the entity level. They can see from there. Then they can break down to line. And if let's say for the production guys on the shop floor, they really want to go deep dive into one of the machine. So you just double click on a machine. What you see is actually like this. It's already interpreted for you. I show you an example here. It's actually the mixing tank where we only take the motor current, which is basically the movement speed of the mixing. So every time a motor move, we get this ampere voltage. We can convert it into RPM by putting the suitable formula. So every time when the motor runs, we know that it's actually in production. And then it stops for a while because you have a changeover, you are doing another batches following into different ingredients. So we can actually know the utilization accurately. Yeah, so this way you could get all the data like effective time. The yellow means actually minor stop, because any stop that is actually less than 10 minutes, we don't call them a breakdown. It is just a minor stop. It could be the operator press a stop button because they forgot to put something. Yeah. And in a non-discrete process, we call this, which is a mixing, which is by batches. It doesn't have one pieces or two pieces. We know that one batch was produced. That's why we call non-discrete. It more interestingly is discrete process. So we have bottling plant, you can have plastic injection, you can see how many pieces was produced by the machine. And then the graph looks a bit different. For example, we take again the counter. So there is a sensor counting the bottles that pass through. We can actually get how many pieces of bottles produced in every minute resolution. We can go all the way down to 15-second resolution with our professional tier software. And then we can also detect, let's say if there's a rejection mechanism there to reject whether the bottle is good, then we can take the reject signal. So whatever that is produced minus whatever there is reject, it will be our effective, the actual output of that machine at every minute. So these small lines, small bars, they are actually per minute output. Yeah. Then you also see this time now with discrete process, you could see there's this light yellow. This light yellow means speed loss. What I mean by speed loss is actually, this is something that the manufacturer couldn't really track in the past, because you can't be asking somebody to capture like this minute I produce 90 pieces. The next minute I produce 70 pieces. As much as people think that their machine is very consistent, but you can see it's not as consistent as we think. Normally, there will be some slower down because of something was forgotten, SOP, or something was stuck. Yeah, so this we can track very, very effectively. And of course, the reason of each breakdown. The reason of each breakdown will not be possible by the sensor itself, definitely, but we allow two-way. One, the line supervisor at the end of each shift, they can do a manual tagging by giving a reason what was the breakdown that happens there. And this is, let's say it is not a breakdown, it was a changeover because they need to change to another product. So then they can specify that this is a changeover. Yeah, you can do that, it's manually done. Or if you have integrated with a PLC, we can take the error code and auto tag into it. But that will be the second phase where it will involve, because when it comes to PLC, it becomes a very costly affair. You are easily talking about 20,000 for the study of the PLC, integrating, buying the module. But over here, we do not need that kind of cost if, let's say, we are taking only the sensor data. Okay. So we can do a Pareto analysis as well. You can imagine that if I have this kind of reason for the next 6 months, by end of 6 months, I want to pull out this particular machine. What was the biggest loss for me? I have this 80-20 rule. In the past, a lot of factories, they just focus on whatever they think that is important. So they could be focusing something that doesn't give much impact because that error only happened once. But it could be the small mistakes that actually keep happening, that actually once you solve this problem, it unlocks a lot of more capacity for you. All right. So we also have this patent pending for SKU specific in Singapore, where we allow us to actually do, because we know every machine has a different product that we are running. Especially in Malaysia, we have one machine that can run up to 10 or 20 SKU. It cannot be setting like, for example, this machine. I'm saying that every bottle come out has a one fixed cycle time. It doesn't make sense because the 2 liter bottle and the 500 ml bottle has a different time on filling. So we allow the integration where this HAS integrated can actually help us by getting the data from the ERP and the MES. With the high byte, easily pump what is a work order to us. We could get that in the morning shift, it was actually running 1 liter. In the afternoon shift, was running 500 ml. And over here, I can set that 1 liter is how many seconds by right should be, and 500 ml. Then the OEE is actually taking the average of these two products based on its own cycle time and get the average of OEE. This way we get the most accurate possible OEE, which we call it SKU specific OEE. Yeah.
Okay. Yeah. Any more slides, Edmund?
Yeah, I will just, last one, maybe I'll just quick through, the rest I will just skip through. The last one will be here, where we can actually collect, for example, if you have 5 different machines together. So all these 5 machines, you can group them together. You see they have different OEE, but you group them together, they have a group OEE. And with that, you can even track Monday to Saturday, when was it run, and all this. So this analytical tool will be very helpful for manufacturers to plan. And even this client, they, for example, they actually shut down from 3 shifts into 2 shifts because they see the potential combination together. Yeah. I think the rest, I think I wouldn't have enough time to go through. So I think I'll stop here.
Okay, thank you, Edmund. I think this is a very excellent way of, getting into details and in depth about the OEE and analyze it in more detail. I think the Pareto analysis part is great, to identify the problems. Since we are short of time, I just have 1 or 2 questions here.
Sure.
One question is about, someone asked about, because the connectivity, Wi-Fi and mesh, this is what from Vincent. Vincent, Wi-Fi and mesh are never quality assurance wireless technology. I know manufacturing clients do not have such requirements. So what kind of clients that use this kind of technology?
No, actually, you're right. In terms of the conventional high-speed wireless Wi-Fi, that is definitely not stable. It's susceptible to interference. We have a different kind of way to actually transmit our data wirelessly, where this allows us to actually get the data very accurately, and we use a lower band to be able to transmit it securely. Yeah, so our clients, like I showed you just now, they are really manufacturers with a lot of machine in the plant to transmit wirelessly. We only have the limitation of 200 to 300 meters between each machine.
So you're not using Wi-Fi in this case?
We are using a Wi-Fi, but we have add on another wireless frequency for us to make sure that the data is not lost in between.
Oh, okay. One final question is about what's your biggest challenge when you engage, with potential client, because it looks very good. So, but is there still something holding them?
Yeah, you're right. If you can see from our reference customer, all of them are almost local-based LLC, but not so much of a multinational company because of the cloud base. The cloud base itself is a big challenge for them to convince them. They want everything on-prem because they worry about the security, the data that go out of them. Yeah.
Okay. So thank you very much, Edmund and Harun, for the presentation. It's an excellent way to show the OEE part. So I guess let's get all the speakers up here. So we like to open to the floor for maybe another 5 more minutes. If there is any questions that you would like to ask any of the panels here, you can either raise your hand or put into the chat. So if there's none, I just like to maybe ask one person from each organization. I think there's none. So because this is the end of the year, we are now approaching the end of 2021 and we're moving towards 2022. So I guess all of us have one wish that you like to see in 2022, either it's for your company or for the whole nation, or something that you like to work, that you like the work that you want to see, Maybe give me a very short one, simple wish list that you would like to tell the audience here. Maybe Dr. Gopinath, do you have anything that you would like to say?
Thank you, Mazlan. Yeah, it has been a challenging year for the past 2 years. I think moving forward, one thing that I wanted is that see, as I mentioned, the Favoriot platform, there are a few components that we want to strengthen it, specifically on data analytics part. So we are in that direction. So hopefully we can offer some data analytics tools specific for some very use cases, which would help in terms of the organizations to build up or improve their own profit margin, or to do something with the data. So that's my goal for the next 1 year, hopefully.
Okay. Next will be Fatih or Murat. Do you have any wish list?
Well, Murat left for a urgent meeting, so sorry for this. Actually, my wishes are beyond the business and technology. I wish for everybody a better new year without COVID and such restrictions, without any issues, and with full of peace. Because without this, it has no sense to dream for more business or more technology. The technology is growing up day by day, but you know, humanity is decreasing as far as I'm concerned. That is why I am not happy with this. We need to find out to respect each other better. So thank you very much.
Thank you, Fatih. Prabodh, do you have anything, a wish that you would like to see? More smart buildings somewhere out there?
Yang Maha Murah, Yang Maha lagi Maha Siani akan kekal
Syafiq, Prabodh is here or not? Tak ada. Prabodh is there, but I think he asked to unmute. Okay.
Yeah, thank you, Shafiq. Sorry,
Okay.
I had to change devices. No, I hope that yes, I hope that the government and awareness on smart buildings, energy efficiency versus their focus on renewable energy will improve, so that through autonomous and through self-running buildings can actually come into play. And I think that government incentivizations on this nature, especially in unified operation centers and the promotion of such unified operation centers and integration, will make the adoption much more efficient, faster, and doable. So yeah, I think that would be my biggest wish.
Thank you very much. And finally, Harun or Edmund? Harun?
Okay, basically, we wish that people would start looking into industrial IoT to improve the efficiency of their small, medium, or large-size companies. And we would like to push for something that is open architecture instead of monopolized by a big company, because we always believe there's nobody who's a master of everything. So we would like to push for this in the new year.
Thank you very much. I think finally, I just like to wrap up everything. I think we have seen a lot of solutions from our industry speakers. Thank you very much for all your talks and your thoughts of also your products. I would like to wish that, you know, all of us to be more prosperous next year and we have a better future. But I see that IoT is gaining traction. Hopefully, it's going to be a very big avalanche we see in the future, especially next year, because IR 4.0 and digital transformation is the two areas that the government has been talking for. So before we leave this whole session, can we get all of us to be on the camera to get a photo session? Can you all switch on your camera if possible? Unless everyone is at home relaxing. So okay, we can get Shafiq. Or you can force them to be on camera. Okay. Hold on, we are waiting a little bit more for the others to switch on their cameras. I hope you guys are still there. You know, that's the challenge of having online webinar, that you will see either the names but not the people there. But hopefully next year we'll be seeing a lot more, you know, face-to-face discussion. So we have our lady from Turkey, KoçSistem. Yeah, hello. Okay, not many of us are online, but anyway, Padma is there. Thank you, Padma, for joining us.
It's a pleasure, Dr. Mazlan. It was an interesting show. I just was watching only your guys talking.
So let's have a photo session. If everybody is already on, or they forgot to switch on their camera. Hello, guys. Thank you. 1, 2, 3.